Today I want to tell you about one of the important consequences of refraction of light. That is apparent depth of the cone. Actually, apparent depth of a pond is always less than the real. How can we say so with diagram this way? Let's say this is a pond and there is an object at the bottom of the pond which is denoted by S. And to make its image, at least we have to draw two rays of light from the object which moves from water to air. One of the ray is taken in this angle and it is traveling from water to the air. That's why it bends away from normal according to law of refraction. And we have to draw another ray also. Let's say another ray is drawn through normal. If it passes through normal, it passes without bending. Both the rays are diverging. That's why they do not meet in really refracted direction. That's why how can we make image of this object? We have to produce them in opposite direction. This ray can be produced in the opposite direction by dot line this way, but another ray we don't have to produce because the same is produced in water also. So if someone is watching from outside, then the image of this object S appears at this point and it seems to be S dash at this height, not at the bottom. This is diagrammatic representation of the apparent depth of the pond, which is less than the real. Apparent depth is actually OS dash only, but real depth is OS. We can write this shortly this way. Let two rays of light start from a point object S of the bottom of the pond and enters from denser medium water to the rarer medium air. According to law of refraction, one passing through the normal, that is SO, passes straight and another bends away from the normal. If the object is observed from outside, then its virtual image appears at S dash. Thus, the real depth OS appears to be only OS dash due to the refraction of light. This is one of the consequences of refraction of light which is very common in our daily life. Okay, I want to stop now. We'll meet in another class.